So the objective for today for the data session is to show you some concepts in this first block about what is citizen science, what is open science, what is open data, what is a data management plan. Well, I don't know what is it, and similar concepts. And in the second block, we will talk about GDPR, okay, data protection law in Europe. We will talk about data collection. So we will show some examples about data collection, I think very illustrative, and we will see some similarities between them and how the citizens implement different approaches about data collection. I think this is a very this is a very important objective. And for the other side, sorry, my children, yeah. Vale. Luego te pongo el otro. Sorry. The schools in Madrid are closed, so there are online lessons, okay? So, well, in the block 2, we will talk about data collection. We will show some tools that you can use, okay, to make the data that you can use for collecting data, okay? Also, we will show a special tool to make data processing, okay? And in the block 3, Ilaria is going to run an interactive session to talk about data quality. That is a very important aspect in citizen science project, because one of the issues in citizen science project is the quality of the data, okay? Because people have the impression that the quality of data in citizen science project is lower than the data collected by or processed by experts, okay, by researchers. And finally, we will finish with data publication. So we will show you how to publish your data, but not only your data. It can be applied to the scientific publications, document, software, any kind of resource of your research. Okay, and if we have time, I will show you something about data visualization. That I think this is a very passionate topic. Okay, because well, I think through the data visualization you can get a lot of information, and you can show to the society in general this information that you are collecting. Okay. So let's start with some basic concepts. Okay, sorry. So I would like to start with, what do you understand by open science? So please don't be shy, okay? Just your first thought about open science, please. Okay, any volunteer? I'm going to choose one. If not, come on, Federico.
I can start, okay? It's something accessible by anyone.
By anyone. So it's public, no? Everyone can access to,
yes, it's public.
To the source.
Yeah.
Great.
It is a good way to have a huge quantity of data with low effort. Because
the low effort?
Yeah.
Great. More comments? No, only 2? Okay, so I will show you my perspective, okay? It's very aligned with Federico said, no? And so basically, you can find here the definition. It's a definition that I like, not for, because it's a definition for my research group, okay? You see the source there. But basically, the open science is opening the scientific project. And we will say opening, it means that all the information is public, all the stages of the research process are public or must be public, okay? We will see that opening not means that, well, I have a file here, a CSV file, for example, or a data set, and this is in my computer in some place in the cloud, okay? So it is not means that. It means that you have to publish all the information, but with a specific metadata to make your data or your resource findable, accessible, interoperable, and reusable, okay? We will study in detail what is these features, okay? So it's open in the scientific process, all the materials, but even the protocols or the workflow you follow to get these results to a broader audience. And when we say a broader audience, it not means only researchers. So open science is the scientific project to the society in general. So you see that the alignment with the citizen science in this case, promoting collaboration in and participation. Sorry. So you can imagine that citizen science is a pillar of open science, and you will see another concepts like, well, it's opening. It doesn't mean open access for scientific publication or any kind of document or tutorial, report, etc. It can be applied to data. Okay, so the data must be open. Not only the raw data, we can say the raw data like the data collected directly, okay, for the sensors or for the people, okay. Also, the data processed, that is the relevant data, okay, to show the results of your research, and for contrast your hypothesis. It's also important the open source, okay, the software you use for analyze, for collecting data, etc., is also relevant for the projects. The hardware, so imagine that you design a specific sensor or device to collect data. Okay, this is also relevant that all this information must be public. For example, the schematic of the of the device, or maybe a video where you show how to build this device, the firmware of the device. We can say the software that is inside of the device. This is also relevant. And of course, citizen science, you have to, you see in the definition that we have to promote the collaboration and participation. And also, and for me, it's something that I love it, is the open educational resource, okay? Open science is more than, well, open all the knowledge that I am producing. It's about also promoting and encourage, for example, students to participate in these projects, okay? You can see a lot of examples. We have one of the pilots here, run by Nilu. Sonja is in this meeting right now. So in this pilot, they design, the students, build a device, make the measurements about air pollution, and later we can say publish a poster, okay, with the result that they get from this device. And I think this is an amazing thing, no? It's something that why open science is amazing, no? Also citizen science. Maybe because I'm an engineer, so I always say that I learn touching things, okay? Not probably if I'm going to a presentation of 2 hours, well, it's too much information. Probably I will forget it in 2 weeks or 3 weeks. But if I can experiment with my hands, okay, I never forget this experience, okay, and this knowledge that I acquire, okay. So let's move to the other. This is basically the research process. You will see that always start with an hypothesis. So I have an hypothesis, I have a theory that I have to contrast, okay? So I have to design an experiment, and basically in the experiment, there is a set of collection of methods, okay, to get data, no? So I have to get data, collect all this information. I have to process this information with algorithms, I don't know, some linear regression, etc. Okay, so once we have the results, we have to use it for contrast this hypothesis, okay? When we contrast the hypothesis, we can publish the results in a paper, for example, or in a journal, okay? Normally, when you publish in a publication, you have a reviewer. So there is a reviewer that he's going to, well, check if all the steps you are follow, okay, are correct or not, okay, from the scientific point of view. So one thing, what happens sometimes is you will see some paper, you see, well, I have this data, I don't know what is it. I apply this algorithm and I magically get these results, okay? So in my opinion, this is not the way to proceed, but with open science, you have to publish not only the paper, you publish the data, the raw data, the final data, and you publish the algorithm that you are producing or design or develop. Okay, so it is more a transparent way, okay, to show your your research. Okay. Key factor of open science. Well, everybody say that we are in a digital revolution. There is a lot of new tools to communicate the results to the society, but communicate it between us. This is a huge revolution. Okay, and citizen science is one of the and the impact of this revolution in citizen science is huge. Okay, because citizen science is basically based on, well, I have to do a task, I need the help of people. And with this tool, I can connect with 1,000, we can say millions of people. So imagine that you have to identify, I'm going to put the example of a street inspector, no? You have to identify street posts or lampposts, okay? So imagine that you have to do, only you or your colleagues, okay? So imagine that you have to map, I don't know, in Madrid, 1,000 of lampposts. You probably never end, okay? But imagine that you put all to, so you contact with all the citizens in Madrid and say, okay, at this hour, we are going to go down to the street, and each one has to be, has to take, sorry, a photo of the lamppost that this is in your house. So probably we will map the whole city, what, in 1 minute? So that is the potential of citizen science. Why open science is important? As I mentioned, one of them, in all research, I think the objective of this research is the reproducibility of your experiments. So to make your experiment reproducible, you need that all the things you need to get the results must be public, okay? So the reviewer or the society or any citizens can take the different element of your research and they can see that the results are the same that you mentioned in the paper. So this is a way to transparency, okay? Sometimes in science, what happens is the transparency. As I mentioned, you will see papers and the authors say, okay, yes, I applied this algorithm. You try to apply and never get the same results, okay? Or probably never get the same result. So this is a transparency problem, okay? And with open science, we can break this model, okay? We can break this model and and make this experiment reproducible and replicate in other places. So imagine that in your pilot, there is, I don't know, in Italy or Germany, you want to export this project, your pilot, to other countries or other cities, okay? So if you publish all your information is public, I want to say all is, it means software, data, methodology, documents, etc. It is more easy to export your model to other places, okay? So reproducibility and transparency in science is really important because when one of the main funders in science, at least in Europe, is the European Commission and the public administrations. So this is public money. So the people have to write, okay, to see the results, okay, and sometimes to understand the results. Okay? So that is very important, the visualization of these results. Next, well, what is the challenges? Well, what happens is in open science, when we try to do open science, there are no incentives, okay? So the incentives for, at least in Spain, is basically, are you published in this journal with this impact factor? Yes or not? Okay, but there is no any incentives, okay, regarding with the open science, okay, to go to the schools, for example, or your publish all your research in public repositories, etc. Okay, so what, this is a problem. And also the main concern is about, as you can see, the scooping, privacy issues, intellectual properties. But what happens is in open science, all is public, okay? But the problem is we are talking about, well, in some cases with some product that you develop, etc. So open science, it doesn't mean that everybody can use your project. Okay, you can establish this. We can say that it's public, okay, but you can establish a license of your work, okay, with attribution, etc. You will see more information about this in the talk of Gefion when she talks about GDPR, okay. But remember that open science, and if you public all your outputs of your research in public repository, doesn't mean that there is no author on the project, okay, on these resources. Well, we'll start with FAIR principles, okay? The FAIR principle is FAIR. It comes from findable, accessible, interoperable, and reusable. As I mentioned in the beginning of the talk, well, it is not only important, okay, to, well, my data is there or my software is there. You have to publish your resource with metadata, with data that put in context your information. So the first feature is the findable. That is mean that all the metadata and data that you are going to generate, okay, it must be findable in this case. So if you put your data, for example, in a Google Drive, nobody is going to find it, okay? And the objective of your research is to make fine, okay, that other researchers or other persons in general can find your investigation, your research. So for that, it's very important to get a persistent identifier, okay? Because if you put your information in Google Drive or Dropbox and later you remove this data, for example, from there, it lost, okay? So when you, so that's, for this reason, it's important to upload or deposit and archive all your data and material in general repositories, okay? Or domain-specific repositories where everybody can find it, okay? The persistent identifier is an identifier that the repository meant in your resource. So always be present in the repository, okay? And of course, you have to describe all the data or your resources with metadata. So basically metadata, there are fields, like title, description, authors, etc. So if you want to find some specific research or some specific material, do you need that all this material has the proper metadata, the proper, we can say, keys to make findable, okay? Because if not, the relevance of your research, okay, it will be lower than others, okay? So I imagine that you learned about the Google. So Google has an index that is built by a reputation, okay, and some indicators. So it is always important that if you develop a website, you have to index in Google good, because if not, your website is not going to be accessible by other people, because probably appears in the, I don't know, in the the 10th page or 11th page, not in the first page. That is very interesting. So this in data, it is important also. Okay, you have to index all this information, fill in this metadata with proper values, okay, to make findable, okay, not only for users, even for other machines, because as you know, well, if you say, like, for example, a specific metadata, you want to see, okay, this person tried to say this thing, okay, but if you are a machine and you program an algorithm, and script to get data from a specific, I don't know, I want the data that talk about light pollution, okay? And instead of light pollution, you put, I don't know, light or pollution in general, this other machine is going, it's not going to understand what you are saying. So it's very important to use vocabularies, okay, standardized vocabularies. So remember, when you upload to a repository, this data must be findable, okay, with a persistent identifier and with the metadata. Accessible, of course. Once you find this information, this data, it must be accessible. Not no, it's right now private. Or if you try to download the information, the data set, you have to implement this protocol that nobody knows. Okay. So in this case, accessible, it means that, well, you can upload it and you can use standard protocols, okay, to access to this data, okay? Even standard formats like, for example, CSV, because if you use a very strange format, okay, nobody's going to understand your data. The other one is interoperable. This is more related with vocabularies. So, well, you find a data, the data is accessible, but sometimes, as I mentioned, for example, imagine that you are tagging your data and you add information, relevant information, like I don't know, the language of the document, for example. So if it's a free field, the people start to put, okay, I'm going to push English or Spanish or Espanol, okay, or in other kind of language. So that the problem is, well, probably it works for the humans, but if you are using a machine to connect to this system, they are not going to interpret this metadata. So they need that be specified or be defined in a specific vocabulary, in a standard vocabulary. So if you put your metadata, all your metadata following vocabularies and standard, okay, it must be you will connect all this information with other sources of information. And this is very relevant because, as you know, we live in the big data world, okay? So one of the problems of big data is, well, the amount of information is overwhelming, okay? So you need to connect all the different systems, and to connect all these different, integrate these different data, you need to, that this data speaks the same language, okay? And finally, reusable. When you put your data, you can establish the conditions to use this data, okay? So my data is public, but for example, if you want to sell or to, I don't know, to build another system using this data, but probably you can do it, okay? Or yes, if I get the correct license, okay? So license is important, okay? You will see in the talk of Gefion about, she talks about licenses, okay? Well, this is the participatory science life cycle. So we will focus today in the data life cycle. I put some stars in the steps of data. So basically the data life cycle starts with, well, I have an experiment. In my experiment, I have to collect data, okay, in this particular way, okay, following this methodology or etc. So once the data is collected, I have to clean the data. We say pre-processing data, but it's basically cleaning the data, no? But I don't know, removing maybe those layers, or I don't know, removing the empty fields, etc. Okay. Once the data is clean, we start to process this data, okay, to get our results, no, to analyze this data. And once the data is analyzed, we can publish this data. Okay, so this is basically the life cycle of data. And we will cover today all the steps in this data life cycle. I'm going to talk you about research objects. So Elena mentioned yesterday that for action, this is not only important, we can say the reports that you are going to generate. It is also very, very relevant, the data that you are going to produce, even if it's raw data or processed data. But also it's important, the slides that you are going to generate. So if you are going to a school or to a co-creation session, etc., and this is relevant for your research, okay? This is relevant for us también. Also, slides, publication, data, software. If you develop a, I don't know, a script, another kind of, or you apply a specific algorithm or use a tool, okay, to analyze this data, this is also relevant for us, okay? So you will see here a research object, and basically the research object is the aggregation of digital objects, and each digital object, as you can imagine, is paper, documents, data, slides, workflow software, hardware, etc. Okay, so we aggregate all together in like in a box, as you can see in the picture. Okay, but it is important not only you have not to think in a research object like just a collection of objects that you put in a box and that's it. It is the relation between these objects. Okay, for example, I would like to know if you are going to generate this data, but you are going to use this one device to generate this data, and you are going to process with a specific algorithm, and you are going to get some results. I will show you an example. Okay, so it could be a standard example of a research object. Look at the relation. That is important part for us. Okay, so basically there is a document where, in this case, instruct tables. This is a web page where you can publish information mainly about your hardware developments. Okay, so you have a document that describes a specific device. Okay, this device generates a data set. Okay, look at this is DOI. DOI is digital object identifier. So this is a persistent identifier for this data. Okay, so there is an algorithm that is placing, for example, you can find this algorithm in GitHub. Okay, GitHub, as you know, is a repository of software. Okay, where the people, software developers, upload software. So you apply this algorithm and get these data sets, okay? And all this information, you can see algorithm and this data set that is basically the results. We can say data sets, images, videos, whatever, okay? Is described and it's analyzed in a paper. This paper has a persistent identifier also and an authors. And also, you can say that this paper, okay, there is a presentation that, well, we can summary this paper, a presentation that maybe you done in a specific, I don't know, conference or wherever, okay, or on a video. So as you can see, a research object, it is not an aggregation of, it is not only, sorry, an aggregation of, we can say, elements. It's about telling a story, okay? Well, this is another more complex research object. This research object is about Deutsche Map. So we did it together with Mark Aguilar, okay? So it's basically the same structure. So we have slides, we have to identify devices, data set that we produce, documents, etc. So I mentioned that because the real challenge we have in action is not only cataloging all these research objects of our projects, pilots included, of course, okay? It's about how to visualize these research objects to basically to tell the people a story. As you see, is imagine that story. I have this device, I produce this data, I use this algorithm to this data, and all these elements, it must be findable, accessible, interoperable if needed, okay? It's difficultly interoperable, and reusable, okay? So we come with you, okay, to build this, we can say this story, okay? because, well, one of the challenges we have in Action is we don't know yet how to visualize problem using diagrams or another kind of tool or whatever, okay? But this is a good thing because I think one of the problems for not only for researchers, for society in general, for citizens, it is basically, well, this is my research. The people see a lot of elements, okay? But I don't know, there's a paper there, I don't know what is the data, or even I have, I don't know, 20 data sets, but I don't remember what is the correct data set, or you have different algorithms, etc. They don't know a global perspective of your research. And this is one of the lacks I see in research and in citizen science projects, okay? And research projects, I think they can, research projects can fulfill this, we can say, this role in this process, okay? With research project, I think it's an amazing tool to show, to tell the story of your research to other, to the society, to the society in general, but on other projects. So imagine that you want to replicate or to reproduce your experiment, your pilot in other place. But sometimes it's very difficult because you only find, well, this is a document there, but I don't know how to apply all the knowledge that the project is generated. And I think with research objects, it is easily to reproduce and to replicate your experience in other places, okay, or even in other situations. So I'm going to continue with the data management plan. So what is exactly a data management plan? Well, it's a document that describes how we are going to handle the data produced in our project, okay? Well, it's a tough document, okay? But I think it's very, very, very useful. And it's very useful do it in the first step of the project, okay? Because they give you a perspective about the things you are going to achieve, okay? From the data perspective, of course. But it's very good to, I don't know, to design the tasks you need, okay? To reach this objectives, these goals in general. And think always in a data management plan like a living document. So probably you have an idea at the beginning of the project. So I'm going to produce this kind of data. I'm going to store this data there, I don't know, in some repository or in Google Drive, etc. Okay. The data management plan is not a judge to say, okay, this is good or this is bad. It's basically to describe the things you are going to do and how you are going to handle your data. That's it. Okay. Of course, there is a reviewer that is going to see the data management plan and say, well, okay, this is not a very good practice for your data. Okay. But this is not a judge. So think in a living document. Okay. So sometimes we see with the other pilots, the pilots on the first call to a data management plan. So well, the problem is in the data management plan to say, okay, I'm going to get this data, I'm going to put there, but in the execution of the project, you'll see, okay, that's not possible. Fuck. What can we do now? Okay, don't worry, it's a living document. If you change in the middle of the project, because you have a plan, but if you have to change it, don't worry. Just only modify the document and that's it, okay? So, well, I don't want to scare with the data management plan. So this is basically the structure. You will see that there are more than 40 questions that you have to answer. Basically, this is the structure of the data management plan. It's a data summary. Basically, it's what is the origin of the data? Are you going to share with the people? What is the format of the data? Okay, basically the structure of the data set, or even the another kind of relevant information. There is another section in the data management plan. It's about fair data. Remember, findable, accessible, etc. So basically, in this section, you have to mention, okay, so well, I'm going to generate a persistent identifier for my data, for example. I'm going to fulfill this these specific metadata fields, okay, about, I don't know, title, description, etc. I'm going to use this license for this data, okay? My data is going to be accessible through the protocol, I don't know, for example, Open Archive protocol, wherever, okay? This kind of information. The other section is the allocation of resources. So of course, if you plan to publish your data or manage data, you have to say, where is this data? Okay, that's pretty important. So this information you have to put in this section, okay? Also security. When you deal with data, you have to say that if we can say that the infrastructure you are going to use for storing this data fulfill some specific security measurements, like, I don't know, but maybe to this computer, only Esteban has access to this computer or something like that. Esteban will have to use a specific password for them, etc., to access to this infrastructure, to this, we can say, this host. And finally, there's a section for ethical aspects. So basically here you have to say, okay, there's any sensitive data, I don't know, maybe full names, telephones, etc. And you have to say that the kind of things that you are going to do with this personal information. Sorry. Okay, so you have to say, for example, you can say, okay, no worries, because before publishing my this data set, I'm going to anonymize, okay, all the information, all this sensitive information. But you have to explain in this document, and you have to say how to do it, how you are going to do it, okay? So not worries, because, well, I have good news. Okay, so basically, if you see in our experience with other pilots, okay, for the first pilots and the original pilots in action, most of the answers are very, very, very similar. So you will see us a lot of examples about how. Sorry. You will have a lot of examples, okay, and templates. And also we have two tools, DMP tool and Connie, that will help you to complete this data management plan. Okay, basically, for example, DMP tool, okay, is a tool that instead of, I don't know, answer 40 questions, we select a set of questions, very relevant question about, I don't know, 10, I think 10 or 11, and the tool generates the document, okay, with all the question answers, okay. And also Connie, that is an assistant together with DMP tool, and Ilaria will show you about this tool, okay, that we use for data collection, but it can be used like an assistant for the DMP tool. And finally, and not least important, is you come with the help with the support of Action Team. Okay, so not worry, we will help you to complete this document. Probably you are not going to enjoy with the document. Okay, but I assure you that this is a very, very useful exercise for your pilots. Okay, and an experiment. Basically, I'm finished.